Dear physics aspirants, right now I have the picture of Michael Faraday, 1791 1867, and uh, here is the acid, basic, and salts topic. This subtopic will come under equilibrium, and acid, basic, and salts find widespread occurrence in nature. Hydrochloric acid present in the gastric juice is secreted by uh, lining of our stomach in a significant amount of 1.2 to 1.5 liter day, and is essential for digestive processes. Acetic acid is known to be the main constituent of vinegar. Lemon and orange juice contain citric and ascorbic acids, and and here tartaric acid is found in tamarind paste, as most of the acids taste sour. The word acid has been derived from the Latin word acidus, meaning sour. Acids are known to turn blue litmus paper into red, B to red, Br, and liberate dihydrogen on reacting with some metals. Similarly, bases are known to turn red litmus paper blue, taste bitter, and feel soapy. A common example of base is washing soda, used for washing purposes. When acids and bases are mixed in the right proportion, they react with each other to give salts. Some commonly known examples of salts are sodium chloride, barium sulfate, sodium nitrate, sodium chloride. Common salt is an important component of our diet and is formed by reaction between hydrochloric acid and sodium hydroxide. It exists in solid state as a cluster of positively charged sodium ions and negatively charged chloride ions, which are held together due to electrostatic interactions between oppositely charged species. 7.10 figure will provide you the information regarding what I have said to you. Sodium plus, chlorine minus, and the electrostatic forces between two charges are inversely proportional to dielectric constant of the medium. Water, a universal solvent, possesses a very high dielectric constant of 80. Thus, when sodium chloride is dissolved in water, the electrostatic interactions are reduced by a factor of 80, and this facilitates the ions to move freely in the solution. Also, they are well separated due to hydration with water molecules. And here the dissolution of sodium chloride in water, sodium ion plus and chloride ions minus are stabilized by their hydration with polar water molecules. Here some introduction regarding Michael Faraday, 1791 1867. Faraday was born near London into a family of very limited means. At the age of 14, he was an apprentice to a kind bookbinder who allowed Faraday to read the books he was binding. Through a fortunate chance, he became laboratory assistant to Davy, and during 1834, Faraday accompanied him to the continent. During this trip, he gained much of experience of coming into contact with many of the leading scientists of the time. In 1925, he succeeded Davy as director of the Royal Institute Laboratories, and 1833 he also became the first Fullerian professor of chemistry. Faraday's first important work was analytical chemistry. After 1821, much of his work was on electricity and magnetism and different electromagnetic phenomena. His ideas led to the establishment of modern field theory. He discovered his two laws of electrolysis in 1834. Faraday was a very modest and kind-hearted person. He declined all the arts and avoided scientific controversies. He preferred to work alone and never had any assistant. He disseminated science in a variety of ways, including his Friday evening discourses. Discourses means debates, and which he founded at the Royal Institution. He has been very famous for his Christmas lecture on the chemical history of a candle. He published nearly 450 scientific papers. Here is the great man Michael Faraday. Now the leftover is here. The molecules former is completely ionized into the constituent ions, while the latter is only partially ionized. Less than 5%. The extent of which ionization occurs depends upon the strength of the bond of the extent of the solvation of ions, and produce the terms dissociation and ionization have earlier been used with different meaning. Dissociation refers to the process of separation of ions and water already existing as such in solid state of the solute, as in sodium chloride. On the other hand, the ionization corresponds to a process in which a neutral molecule splits into charged ions in the solution. Here we shall not distinguish between the two and use the two terms interchangeably. So we have discussed acid, bases and salts. In next video we will discuss Arrhenius concept of acids and bases. We will meet in the next session with a lot more. Till then, thank you very much.